Hello and welcome to this podcast, Semiconductors and Critical Minerals. I am Dr. Sriganesh Rao, researcher under the Maitri program of DFAT Australia for developing a roadmap for Australia-India strategic collaboration on semiconductors. I have with me Kailash Sriram, MD and CEO of IPACS Australia. He is an engineer, researcher, and entrepreneur with more than 50 years of experience in industrial engineering, enhancing future technologies. Currently, he is a senior industry fellow at Adelaide University, leading research for the next generation technologies, including industrial IoT, digital twin dynamic analysis, mining and operational sustainment, critical minerals extraction, and beneficiation. Starting his engineering career at Mecon, India, he moved to the American Bureau of Shipping as a worldwide technical services director. He had earlier co founded an engineering consultant company called Kutla Engineering, which was in the field of oil and gas platforms and in industrial processes. He has worked on technology projects at Royal Australian Navy, Lockheed Martin, and Rolls-Royce, and the Defense Science and Technology Organization. He has handled many multi-million dollar specialist projects, such as offshore platform extensions and modifications, ship modifications and upgrades, industrial projects including mining, chemical plants, cement plants, mineral processing, etc. Mr. Sriram has served and continues to serve on numerous governing and advisory boards of technology, Institute of Marine Science and Technology of UK, South Australian Defence. He also has an MOU with Adelaide University and DST India for enhancement of collaborative research in grassroots and evolving technologies. He is a patent holder of combustion control system. Welcome, uh, welcome, sir. Welcome to this podcast.
Thank you, Dr. Sriganesh Rao. Namaskar. Suddenly I feel, where has all the 50 years gone? You, you give such an introduction. I'm a little bit amazed myself. Anyway, it's been great to get involved in putting up this podcast about the Maitri Grants that you just said. And I'm happy to provide whatever little answers that I have to the questions that you have. Please go ahead.
To start with, sir, why are semiconductors so critical to a country's economy and national security today?
That's a really good question. Maybe because semiconductors are virtually in every aspect of life that you have. Let's say from supply chains, shutdowns, disruptions, governments weaponizing supply chains for political reasons, unfettered access to microchips in economic and national security, in the defense sector, in your cars, everywhere that you look at, semiconductors are important and they're taking up. They're virtually thinking on your behalf. So it is a part of evolution into the next, not even the next century, it's the next decade or the next year. So it is a very important feature and very aggressively required both for Australia and India as two close friends.
We know that Australia is very rich in the critical minerals. Uh, so, what are the critical minerals available in Australia which should be of immense use in the India semiconductor fabs?
Australia has always been great at mining, and we have some of the most advanced, or not really advanced, available, accessible critical minerals. Out of the 22 which are there, we look at silicon, gallium, germanium, tungsten, cobalt, nickel, and lots of other things. But the problem is how do you extract them and how do you beneficiate them? We at our university have an institute called IPACS, which has been the pioneer at mining for many, many decades. It has actually set out a lot of the present day solutions in extraction and particularly in beneficiation. So critical minerals of various types, or even rare earths as we call it today, Extraction is getting to be critical, and we have identified mainly 6 different streams of process of beneficiation that's come out of us.
Mhm.
And what is required is mineral classification and then the chemical side of it before you decide what sort of processes are you going to go through for beneficiation. So, in effect, we have quite a number of the important graphite, if you like, titanium, lithium, and extracting and beneficiating. Would that answer your question?
Yeah, yeah, very much. And we heard that Australia has a strategy on critical minerals. So what exactly is this Australia's critical minerals strategy?
Australian government has set up what we call as the Australia's critical mineral strategy going up to 2030. The vision and the mission is to grow the critical mineral sector. Australia, as you know, is a very rich geological reserves, has extreme expertise as extracting materials or minerals, reliable producer and exporter of energy and resources. We pride ourselves in trying to break barriers of any misconception between friends. So, Australian and Indian collaborators have worked out the process and requirement of sharing wealth together. We are also looking at providing critical minerals for things like the defense sector, the energy sector, which will actually grow a strong and secure governance, ECG credentials, and status as a trusted friend
Mhm.
to decarbonize the global economy, creating new industries, mineral refining and processing, manufacture of clean energy technologies, and actually what leads up to is supporting well-paid jobs, skills pathway for future generations, genuine partnerships, shared benefits with regional, international friends and our First National or the Aboriginal communities who actually own the land. So Australia has got a very clear and precise path forward up to 2030, particularly on the critical minerals and also on the rare earth.
That's great to hear. How can this strategy enable semiconductor collaboration with India?
Um, Interestingly, the Indian Semiconductor Mission ISM2 is meant to accelerate offering 50% capital subsidies for fabrication and assembly. Australia has geostrategic and economic footprint of critical minerals for fostering global partnerships through what we call as design linked initiative DLI schemes enable strategic long-term tie-ups with friendly nations for technology transfer which requires R&D of course and secure supply chain diversifications collaboration strategies which include to an extent financial incentives and subsidies. Indian government, as I understand, provides 50% fiscal support for setting up semiconductor fabrications and display units. Focus on design ecosystem. DLI's scheme supports startups and IP houses with design infrastructure, reducing prototyping, cost fostering innovation, partnership internationally such as Renesas, or there are so many other companies. What is important is coming out of the Quad, which India, USA, Japan, and Australia have signed. That brings us into an area where we collaborate, including on the nuclear physics and the critical minerals indirectly. So that's a very strong platform which we think is something to be explored. Obviously, it requires confidence from both sides, and in some way, it requires people like you and me to bring it together.
Sure. Okay. India and Australia have signed a trade agreement treaty called as Economic Cooperation Trade Agreement a couple of years back, and now is in the process of coming out with a comprehensive economic agreement, which is called as CECA. And this ECTA allows tariff-free import of lots of Australian goods into India, and also encourages business-to-business collaboration, people-to-people collaboration, and you know the R&D and the research collaborations and things like this. And it also covers services and mobility. So how important is the talent movement? Since you come from the university, how important is the talent movement, that is student, researchers, and engineers for semiconductor collaboration?
In our university, we have what we call as the Future Industries Institute, which I've been heading for quite some time. And in that, we have got a lot of the so called clean rooms for each of the technologies from nano to various advanced manufacturing. And what we offer is for the Indian academies to come here, spend time with us. We learn from them, they learn from us. We treat them as equals. They come on short, long term, because this platform, Economic Cooperation and Trade Agreement, provides you the opportunity to look at how can we elaborate or evolve out of just a handshake into something tangible, something which can benefit in real value terms. As I said before, this does require to emerge a lot of technologies such as quantum or mainly um, the high value fabrication, which requires very, very intense dedication. So this does bring in an appreciation of the skills, of the intellect, of the caliber, both from India and Australia. We have, due to concentrated focus on the research and R&D, Australia has been quite noted for that. And we have advanced, say, for example, on the quantum, I can tell you, a friend of mine, a colleague, Professor Heike, has actually innovated fiber optics where it say inserts a broken piece of diamond, and that accelerates the transfer rate by about 10,000 times. So that
Mhm.
sort of technology is unique. Bringing that into quantum computers, which India is good at, you need to collab both. In other words, the quantification, qualification of just not the processes, the R&D, but also the people. I hope that is useful in, or did I answer the question correctly?
Yeah, sure. Yeah, as we know, in India, we have the India Semiconductor Mission, where there's a huge investment by the government for setting up of semiconductor fabs, OSAT, ATMPs, and fabless design, etc. So coming to the fabrication segment of the semiconductor value chain, what are the opportunities for collaboration between Australia and India in the fabrication segment?
A very good question because I was directly involved in some of those. So I can say that with a lot of pride to say we have, we're good at the building blocks,
Mhm.
the various little steps that you might call, or the structured end fabrication requires you to be specific and clear about the interim each state of fabrication. Let's say you want to introduce nanotechnology, you want to use surface preparation, or you want to use imprinting. We've got equipments in our laboratory which can imprint on a nano, on a very
Okay.
tiny scale,
Mhm.
a complete circuit, which is
Mhm.
essential for semiconductors anyway. We are not very big in semiconductor manufacture, So we would like to collaborate with India because India is going to be the major manufacturer in future, as we understand. And we wish you all the very best of luck. And collaborating together, we think we bring in the intellectual R&D, IP, and a collaboration where we can expand not only economics for both countries, but interdependence so that we don't have to be losing on the supply chain difficulties which might arise, which are arising. So to feel secure that we are on the same platform.
Mhm. Would there be any potential challenges in this, in the collaboration?
Yes, challenges are confidence building
Mhm.
primarily to respect and evaluate each other because on an academic level, you will find that academicians do agree
Mhm.
to an extent to say, okay, we are exploring the unknown. To set the unknown into a workable format is where collaboration and understanding of each other's potential, most importantly, the respect for each other, to feel they are a team. The countries at the high level are doing it. The prime ministers of both countries have shaken hands. Now it's for us to make it happen. And to make it happen, we need to expand on the friendship that we have, the trust that we have. There is a little bit of a challenge of saying how much of IP can go, the background or the foreground IP. These are all issues which need to be discussed. Also, the funding issues, because so far, as I know, Australia is very generously contributed to bringing technology together. But now, with India as the main source, I understand India is now going to spend something close to 11.83 billion Australian dollars in semiconductor industry. We would love to be a part of that to say we are also happy to contribute. So those sort of funding issues, they're not difficult because it's already allocated. How do we combine together as a single platform to be able to expand and improve on it? It's something of a challenge. I agree on that.
So going
You would have
forward,
answers.
yeah, I mean,
Sorry,
going
you
forward for
definitely
the,
have an answer to all that. I don't.
yeah, we need to work together on all this. I mean, both the country has to work
Exactly.
together on this to make this
Yep.
happen. Talking about the next generation chips, what could be the emerging semiconductor materials and technologies which will have the most potential for the next generation chips?
I did make a list of the things. Just give me a minute.
Sure.
Emerging materials and technologies. What we look at is gallium nitride, considered
Hmm.
most important semiconductor material since silicon was the initial, which
Yeah.
is 1,000 times increase in efficiency, high frequency, great for power applications, silicon carbide for electric vehicles, as you know, and high power temperature applications, graphene, known as extreme speed and conductivity, representing future wonder material, has been considered as a wonder material because suddenly we find some of those hidden so-called critical minerals which we've just been exploring have better capacity to retain, restrain, and evolve. Things like that we have seen semiconductors, including materials like indium phosphide for specialized fast and energy efficient chips, bio-based semiconductors are emerging, and obviously things like cobalt, lithium, nickel, rare earths. While India offers scaling manufacturing and downstream processing, we would like to be the supplier of the material, go through the beneficiation process, provide the R&D of how to implement all this into the nano manufacturing.
Okay. Yeah, you talked about the R&D research. How can Australia and India collaborate to accelerate the research in these areas? Does the government support, are there any specific Australia-India kind of partnership in the research?
There are quite a few, like the one that you had, Maitri, the Australian Indian Strategic Research Foundation or funding.
Mhm.
There are a few like that, at least about three per year. Now, some of the things that we felt, we so called professors at the university or the so called intellectuals, if you like, we would like to take this into a stage where we have a direct interaction with people like you in the manufacturing industry who have seen the value of the product. We would like to contribute to that through a collaboration which probably extends back into what India is offered in the semiconductor industry. So if you reach out, we're happy to reach out. There are things like CRCs and CRCPs which keep going, but most of it would be at an academic level. The industry needs to get involved because
Okay.
industry will appreciate and understand what are the gray areas, what are the strong areas, what are the modes of improvement, whether it's on the fabrication, the microfabrication, the nanofabrication, imprinting, prototyping, and protons. And all of this together will bring to a stage to say, should we bring in the industry? That I've been also talking at various levels in our country, in Australia, to say India is ready. We also should walk as fast as we can so that we have a trust between us to take this forward.
Yeah, you have brought in a very good point. So normally we always hear university-led research collaboration, but here you also mentioned about the industry-led research collaboration, which is very important. Yeah, that's good, sir.
Just a
Um,
point there.
okay.
I have worked through some of these evolving technologies in Sweden at a university called Luleå,
Hmm.
where in the campus,
Hmm.
it's called Aurorum. In the campus, we have all the major manufacturers of Sweden, whether it's automotive, whether it's telecom, whether it's mobile phones, or even the defense. They're all located there with the collaborated, it's a place called Centrium as well, where they fund
Hmm.
because they want to see where can we take it tomorrow. Some of the research that we did there, one of the this which I was involved close to 30 years ago, was in flotation. Today, that is the only process of looking at beneficiation of these critical minerals, bubbling, the bubbling and then capturing the bubbling. 34, 35 years, I think, ago, we actually
Hmm.
introduced cameras to capture them.
Okay. Okay.
And then with the 286 and the 386 computer, we did manage to evolve the technology. Today, it is famous all over the world. It's something which came out of that, and proudly I was a part of it. Sadly, I'm an old man.
That's great. That's great. So India is attracting a lot of investments currently in the OSAT area, that is outsourced semiconductor assembly and test. Is there any potential for Australian companies to partner in this to provide, say, high-end packaging technologies and expertise?
There are, there are, because India has got our main um, national income is from the mining sector and the farming.
Mhm.
The mining sector has got a lot of technology where we were involved in looking at the futuristic idea. What's going to happen 10 years from now when the materials will not be as commonly available? So, recreation, reusing. So, they would also look at a lot of technologies. And it's a point of talking to them. I do have friends in that sector who would be involved, and they have shown an interest. I did mention about the possibility, and there is an interest. Now, to come to a platform, you need to create some sort of coordinated, let's say collaborated organization or institute or something like that to feel equal ownership and responsibility. Without that, what will happen is you will have the technology side, you'll have the manufacturing side. They may not talk to each other because they've got different objectives, different ideas of expertise, and to collaborate it towards one goal of saying, let's put it together. It's something I've been talking about for quite some time. So good you mentioned it. There's something to be explored, and it's the right time now with a very progressive government in India and with the collaboration that India and Australia have got with the free trade agreement and with the prime ministers agreeing through the Quad or whatever, we have come closer. So this is the time to exploit our opportunities. I agree with you on that.
Yeah, you had mentioned about the collaboration in the research areas. Um, will there be any issue of IP sharing arrangements between Australia and India in the research area? Or, what I mean is like, will the research institutions, like examples, the universities, provide access to the engineers coming from the other countries to advanced semiconductor process equipment, say for prototyping and training? So, what kind of commercial or IP sharing arrangements would enable this?
That's a good question. We do allow and we welcome people
Mhm.
from India. They come and stay here. We have people from all over the world, including America and all that. They come to our institute because we are pretty advanced in a few things. And sharing of IP, as you know, there are two, the foreground and the background IP. Background IP is more on the research, which is held back because for further research, if you don't have the background IP, you will not be able to go forward. The foreground is specialized for a product. So in that A product, there will be adjustments or continuous requirements. Let me give an example. Let's say critical minerals,
Mhm.
beneficiation. As I mentioned to you, there are 6 different streams. Now, when you have a product coming in, when you classify what sort of minerals they are, and you look at the chemistry, and then you look at the processing systems which are required, the bigger question to us as researchers and scientists and with practical experience, we wonder how much of, say, type A to be done.
Mhm.
If you do type A aggressively, you might lose a lot. If you
Okay.
underdo, type B would require to make up for it, but anything lost cannot easily be remade. So there is an optimization process. In other words, I was telling my guys yesterday, we need to consider this as a living identity because the continuous change of the incoming product, the outgoing product you are aware of, which chemical you need where, how much. I'll give you one another example where we have perfected. We have mines, so due to the rains, we have rare rains, but when we have it floods. So all the minerals get washed into the tailing dam.
Okay.
Now the critical minerals go into the tailing dam. How do you extract them? We have perfected that by certain coagulants, certain polymers, which can extract and separate A type of chemical, B type of chemical, T type. Out of that, we bring them out and then expand it further to go for even uranium.
Oh, okay.
So the expansion of the technology we are aware of. But when it gets into a manufacturing stage, whether we set up a manufacturing here and supply it to India or send a raw material down to India, which is expensive. If you need 10 grams, what's the worth of sending 2 tons of things which you're not going to use? You need those 10 grams. So the beneficiation process, this is a topic which I've been talking to our government, state government also, saying whether we should set up a pilot plant or a demonstration plant. Collaborated with India, and I find a lot of interest coming out of India. And I'd like to talk to you more on that on a separate platform
Okay.
because that I think will set the tone of people coming from India to here and here to there as a single entity. You have an organization where you go to different departments, different locations, spend time, expand, collaborate, and conceive and perceive solutions.
Yeah,
We're
I'm
happy
sure
for
that
that.
I'm sure that the recent ECTA trade agreement would enable such kind of talent exchange programs and things like that. And it'll
Absolutely.
allow Indian, say, students, engineers, and researchers and entrepreneurs in the semiconductor area to easily work between India and Australia.
Yes, we find Indian students, my background is in India, so I'm not a real example, but we find there's a lot of intellect, untapped. Tapped
Okay.
intellect has been there, but untapped intellect is so much. When I was in Delhi with DST and I spoke to some of the research institutes there, and I was amazed with the dedication and the devotion. What was missing in my observation was the intuition to contribute.
Okay.
Sometimes it goes as status quo. So you need dynamic forces to say, look at tomorrow. And I like the way your Prime Minister Modi ji has been promoting, and our Prime Minister Albanese, bringing us together to say, we have the intellect, we have the confidence, we have the government support, let us move.
So you mentioned about the DST, which is the Department of Science and Technology in India. You have an MOU with them along with the Adelaide University to kind of work on the new areas of research. So can you kind of give some examples of what kind of research is being looked at as a collaborative research between your university and the DST India?
Yes, this was in 2024,
Okay.
where we signed in Delhi
Mhm.
an agreement. It was supposed to be between Department of Science and Technology, Ministry of Science and Technology, with a division called National Innovation Foundation, based in
Okay.
Ahmedabad and Gujarat.
Mhm.
And I was involved in mentoring the
Mhm.
researchers. Interesting of NIF, they've got more than 60,000 innovations. I was amazed.
Mhm.
They invite ideas from anybody in India, a
Mhm.
school kid, uneducated, educated, all those with those interesting ideas to enhance or improve livelihood, if you like, well being, if you like, and into the farming sector and all that. And
Mhm.
government of India gives them certain amount of money to make a prototype,
Mhm.
and then that is evaluated. And then government of India actually enhances it, gets an IP globally, and some of the products are actually sold on Amazon. So
Okay.
what happened is these things have to be analyzed. So I have been involved in analyzing them on behalf of, as an external, if you like. And
Okay.
many a time I had to use platforms or explain to them platforms like the multiphysics to say a product, what's the benefit, what's the
Mhm.
material, what's the end use, and how is it support. And I was amazed, little kids coming out with ideas which may seem silly, but you go to any small shop in India and you'll find the products available. So through them, we have also been talking about enhancing one of the critical areas which India is lacking is on the water, quality of water. Through the Australian Indian strategic, research funding, we were
Mhm.
looking at improving the quality of water, including your hometown of Bangalore
Mhm.
and uh, Yamuna River, Ganges River. All this we have certain domain sovereign technology or intellect within our division, which I head, called SIRM, Sustainable Infrastructure Resource Management. and on the water quality. And these were things that we're looking at. And what came out of that was I was talking also about the mining and critical minerals. It doesn't directly fall under their purview, but as a part of the Department of Science and Technology, I said happy to support. And I've
Yeah,
actually
interesting.
told them, I've also told them about this podcast which we'll be making, and they want to have a copy of it.
Okay. Interesting you mentioned about the water treatment. Yeah, we know that ultra pure water is required for the semiconductor fabrication.
Yeah.
And what are the purification techniques which are used in Australia for creating this ultra pure water? And also probably what are the processes which are used to conserve water uh, pertaining to the recycle and on the reuse?
Yeah. That's a that's an interesting question, Dr. Rao. I've always maintained because Austrade and DFAT, Department of Foreign Affairs and Trade of Australia, has a very strong collaboration with India to talk about improving the quality of water, whether it's potable water, industrial water, and also good on the high intensity that's required for semiconductors. So some of the things that we have looked at is, most of it is common. Reverse osmosis is what they talk about, but deionizing, decarbonizing, ultraviolet treatment, all of these require, including the organic carbon and then filtration. All of these generally people follow. But we also looking at what is the ultraviolet range of the water to look at the impurities. We have invented sensor, which is more of ultraviolet based, to look at what's the wavelength. That wavelength contains the quality of contaminants. To remove the contaminants, then you need to work out various different, to come to, as you rightly said, zero liquid discharge systems. That's probably what we are aiming at. And ultra pure water,
Hmm.
if you can use that word. So we have got the expertise within our division.
Okay.
And some of these spectrometers, which are in the form of ultraviolet cameras today, to deliver them into a phosphorus series or something which you can analyze on a continuous basis. There's no point taking a sample and analyzing it and then the next day's sample in between so much of impurities have gone through. So online systems is what you need to look at. And that's something which I've been heavily talking with DST. So
Okay.
hopefully one of these days we'll combine together. Mainly, as I feel, Dr. Rao, the industry in India, they are the end benefiters
Mhm.
and they are the source from which it goes out.
Mhm.
So they feel the importance, but they don't know where to look at because I did get calls from various people. And I thought, sitting here, I would not know who's who.
Okay.
I know you and I respect you. I respect your knowledge and your caliber. And I think we should talk more on how to bring the countries together on this very important issue of the water. I've not mentioned all the various things because it'll take me a long time to go through that. But briefly explain to you the fundamentals of how we want to address the water, ultra-fine water quality, as they call it.
Yeah, see, Australia, we all know that in Australia has very rich deposits of the critical minerals and is able to extract them. But to process it to make it semiconductor grade, um, so normally it also depends on overseas. Can Australian mining companies and Indian, say, chemical manufacturers form joint ventures to produce semiconductor grade materials locally in both the countries?
That's a good question you asked because I've received requests
Mhm.
from some of the Indian companies Some of the things that are a drawback or a challenge, starting from the fundamental working processes, the labor laws, the taxation,
Mhm.
and in some sort of way, the workers, um, how do I put it, caliber, training, and commitment. Having said that, there are mining companies which have come here,
Mhm.
but they are purely for extracting and sending things like coal or iron ore, things like that. But in critical minerals or in rare earth,
Mhm.
you got to beneficiate them at the source. Otherwise, you're transporting too much of material. Let's say some of these critical minerals or rare earths are 0.1%. What about the 99.9%? How do you extract? So the extraction process is based on characterization of the minerals, the mineral, let's say, chemistry, and including them into various types of processes, including something which I did 30 years ago, is ion exchange,
Okay.
changing the very structure to make it stable. Some of these are very unstable. Some of them, as you know, uranium, for example. But it's not that topic that we're talking about, but things which are required for critical minerals. So it's an area where definitely together India and Australia have to expand. Because once
Okay.
in Australia feels we are secure with India, the end market, there will be enthusiasm. Likewise in India, if they feel they have a partner whom they can rely on, not as a country, but as groups of intellectuals or companies that respond on equal to equal basis. I think that will bring us all together, and that's something I look forward to.
I'm sure this will happen, with the current trade agreements like the Economic Cooperation Trade Agreement, um, which basically encourages joint ventures and collaborations between the two countries. So definitely, it enables these initiatives. See, clean room facilities are very important for the semiconductor fabrication. Does Australia have any expertise in the clean room facilities which are required for such fabrication?
Yes, we do. In fact, in the labs that um, I handled for quite some time, we've got some of the most clean rooms,
Hmm.
whether it's on the nano or imprinting or protonic or all this. We've got a lot of these clean rooms where
Hmm.
we are conscious of extreme commitment of the people. Because you might
Hmm.
have a great clean room, but if you don't have the commitment of the people entering in and out, we do follow ISO 5, ISO 6, and ISO 7 clean room, focus
Oh,
on
okay.
nano electronics, CMOS, and gas devices,
Hmm.
often producing below 50 millimeter nanomaterial, nanoscience hub. We have approximately 700 of ISO 5 clean room space for deposition, etching, lithography, metrology, dedicated to class 10,000, soft lithography clean room, including specialized labs for SIC and SI deposition. We have recently expanded into microfluids, organic electronics, and novel semiconductor materials, compound semiconductor materials like GAS and INP houses, metallic, organic, chemical vapor deposition. So we got a lot of those. And that's the collaboration where we would like
Hmm.
the academicians and the intellectuals in the field from India to come and spend. And due to, as you rightly said, to the new collaborations that India has, Australia have signed, it has opened it and made it easy for people to come. We can at least say we have real good quality clean rooms, how it is to be used or modified or adjusted. You know, you design a clean room to be the cleanest room, but there may be something different which is required. Industry will require something different. To make those subtle adjustments and then experiment and see whether type A, type B, type C would work. We have that facility, yes.
Yeah, I'm sure such expertise would be of immense use in India. Yeah.
Both ways, I think, to be honest, both
Okay.
ways.
We also hear that quantum technologies are often discussed alongside semiconductors as a future-defining field. What are your thoughts on the India-Australia collaboration in quantum technologies?
There have been collaborations going on at an academic level. Coming back
Mhm.
to what I
Mhm.
just mentioned about Professor Hake,
Mhm.
you know, I did tell her about, we did speak to DSD about it
Mhm.
to say to integrate a technology into innovation. Quantum is now, next to semiconductors, probably the most important field.
Mhm.
And two important things there definitely are quantification and qualification.
Mhm.
Quantifying something to the highest degree of availability or possibility to create a qualitative analytics. A little unknown defect, either in the quantum sensing or quantum computing, would have erroneous results. How would we collaborate on that? It's something which I've been talking about, and I'd love to progress on that because um, everybody talks about quantum nowadays. There are arrangements from university to university level, which goes as teaching. Beyond teaching, we have set up a quantum institute, but who is the end user? As I rightly said before, or as I often said, is the industry. The government holds a lot of the intellectual side. So it could be government to government, which will be too slow because there are so many hurdles. Whereas coming together on a platform like what you have been talking about, we're happy. And I think that is as much required as the critical minerals, the semiconductors, and the rare earths. That is the future. 21st century is slowly getting close. 22nd century will start talking about things which today we are imagining, like the AI conference that you just recently had. Eye opener, you know. So for those sort of high-end usages, unless you have conditioned restrictions to ensure that adverse analysis doesn't take place, which is a probability, you would need to ensure that your quantum computing or sensing is as accurate as possible. Nothing is absolutely accurate. I agree on that. But to this day, what we can achieve should be the best of the day, is how I've looked at it.
So I've taken a lot of your time today and got all your expert ideas. Any final thought on how do you see Australia-India collaboration going forward?
On a government level, there's a lot of emphasis.
Mhm.
But I think we need to talk about the industry, the corporate world of India, because you've
Okay.
got a lot of corporate expertise, whether it's in IT field or India is a heavy manufacturing country, intellectual in a lot of ways. So we need to think about bringing those together, whether it's through some of the departments that you are a director of, Indo-Australian Chamber of Commerce, but it should go to the real people there to say, yes, we want to collaborate. And that needs a lot of confidence, and people like you bring in the confidence. I did have the Australian Indian Chamber of Commerce or Business Council, which came and visited us and spoke to me about it. And all that I said is, yes, you have to work on it, induce confidence that we can work jointly, not as left arm and right arm, but as single entity. And the handshake is always there.
So that's nice. So thank you once again, for actually providing your valuable time and your ideas on this. So thanks for participating in this podcast.